And welcome back. Yes, I've got a proof of concept to show you here. A little bit controversial perhaps in its subject matter, but it involves writing a very simple app here on the Android phone. Sorry, I haven't got any Apple phones or anything, so I've absolutely no idea how to do it for an Apple. But for Android, it's really simple. And in fact, if you want to know how to write the ultimate in simple programs for an Android, just to turn an LED off on your Arduino, you need to look at videos 36 and 37. My goodness, that's going back a long way, isn't it? Probably 4 years or so. But it was really simple, and it was just a little tiny app on here that said on off, and the Arduino also replied back to the phone saying this is what I've done, and the phone read that in. So that's the ultimate simple app that you can write for your phone, an LED on off. This sort of builds on that really. I wouldn't go directly into this if I were you. Well, up to you of course, but you know, learn the basics first. However, let's think about the controversy then about this whole issue of an intelligent phone charger. I want to give a shout out to my sponsor JLCPCB, manufacturers of custom PCBs, made simple. One of their new features that's coming up shortly is their Smt Assembly process. And their webpage contains a lot of information about what their capabilities are and some various very common facts. If you prepare your PCB using Easy EDA, you'll find that when you place components, you have the option of using their LCSC assembled catalogue. As you can see here, I've just chosen the IC that I'm going to be using in a future project, and it's come up as part of the LCSC assembled list. That means they can pick and place it for you on that board. If you can, try and use their basic list rather than the extended list, which means they'd have to change the components in the pick and place machine. Designing a board could not be easier using Easy EDA. And the fact it links into the JLCPCB website is going to make ordering an assembled SMT PCB an absolute breeze. Why don't you try them out today? Let's think about the controversy then about this whole issue of an intelligent phone charger. Now, when you've got a battery like this one here, like any LiPo or lithium ion, they do say, let's get one out, right, so we've got one here, right? Now they say the worst thing you can do to these, oh look, 5,000 milliampere hours. The worst thing you can do to these is stick them in your charger for this, or your you know, your drone charger or whatever it is. Get them up to 100% fully charged, and then just chuck it in the cupboard ready for next time. Yeah, absolute worst thing you can do, because this is now pumped up to the extreme. Imagine a beach ball or a bicycle tyre pumped up to the absolute maximum. It's stuffed full of energy, and you're just leaving it in a drawer for the next month or something. Doesn't do it any good, allegedly. Okay, and that's been the thinking really with phones as well. Should you in fact charge your phone up to 100% and keep it there all day long, which is what I've done, I must admit, for years. And for years, literally for years, at least 2 or 3 years, I've wanted to create an app with an Arduino and things to say, when I get to a certain percentage charge, let's use my pointer, not my fat finger. When I get to a certain percentage, user-selectable, the charger will switch off. Now I use a charger like this. This is just a little stand really. So I'll put it on here in my workbench, and it used to be on my desk at work, and it just sits there all day long while I'm, you know, listening to music or reading messages or whatever. So 100% from, you know, 8 o'clock in the morning to 4 o'clock at night. Slight pause in the middle of the day when I have a lunch break. But I mean, basically this poor little battery on here is stuffed full to 100%. Absolutely no need for that, of course. If you're running on battery anyway, if you're running on a charger anyway, it's the charger that's powering everything up on here, and all you're doing is stuffing more and more energy into the phone itself. So what this does is to say, when I get to a certain percentage, like 80%, stop charging, okay, and let the battery die down a bit. When it gets down to maybe, I don't know, 70%, start charging again. So it just oscillate between 70 and 80. Now, of course, it might never get down to 70, depending on what you're doing with the phone. If you're making extremely light use of it and you're dimming the screen or whatever, perhaps it won't even get down to 70, but let's assume it does. This then talks to the intelligent part of the Arduino via the Bluetooth controller there to say, oi, I'm at this percentage and you should be charging at X percentage. So do your logic and either switch the power on via the micro USB or USB-C port at the bottom here and do your stuff. Yeah, so it sounds pretty simple, doesn't it? Now this is the actual application that I've built and downloaded, but there's a newer version of this that I've got in development at the moment. Let me just load that up just to show you. Right, I've just started up a little application on here that sort of links into the development environment on here. And as you can see, the actual application has sort of moved on a little bit. Basically, I've got, you know, the minimum, maximum, what I want to charge at. I think these two are already there. I've got the MAC address at the top. That's just a test button, that check battery, that isn't really required anymore. It's all automatic. So what does it do exactly? Well, let me get these bottles out of the way. Yes. Now, when you're watching this video, have no fear of any viruses coming down the line, despite how sick I've been. I'll put all this stuff all over my hands and everything else that I'm touching. So I am absolutely virus-free, as is this video. Okay, so no flu virus, no coronavirus or anything else. Right, that's cleared that out of the way. Let's move that blue tack out of the way. Right, so basically this app is running, okay, and it says, what's the battery percentage? That's the whole thing, isn't it? And then it transmits that value, that battery percentage, to this little HC05 or HC06 device that's connected to the Arduino. And as I say, if you want to know how that bit works, look at videos 36, which has done this bit, and 37 that does the very simple app on here, the on-off LED, and it really is simple. Now, there's been a slight change in the development environment. The original app that I wrote for the LED on-off was the MIT app inventor, which I tried to use for this, and I loaded it all up and I said, right, where's the battery widget thing to monitor the battery? And it goes, oh, we haven't got one. You have to use something called Appy Builder, which is sort of the next step up from MIT App Inventor. So I loaded up Appy Builder, found the battery widget, which basically just means you can interrogate what the battery value at the top is saying there. And then I tried to build the application into a freestanding app, and it goes, oh no, I can't do that. We've sort of closed down really, and you have to use something now called Codular. It was called something else, the name of which I'll forget at some. I'll put it on the screen now. That's what it used to be called. Now it's called Codular, not modular, Codular. I don't know why. Or perhaps it's Codular. Whatever. Anyway, that has everything we need. Basically, it allows you to interrogate the battery value. It allows you to connect via Bluetooth to this. So you just pair this once normally, as you would do. And from then on, it just talks. It also allows you to have a tiny DB. That's the actual name of it. Basically, it's probably a file or something on your storage here. So you've got a field called perhaps battery level and then a percentage. And I've got, you know, these things here, these max and the min, and whether these check boxes are checked. So on startup, it will just retrieve all the previous values and set them so you don't have to do anything. And the whole point about this app is it should really be running in the background, which is another thing I had to get working. So on Android, you have to say, don't start killing this process just because I've pressed that central button there, that middle button, you know, which takes you back to the desktop, and then things are running in background. Well, under normal circumstances, Android might well kill that device, not the device, the application, because it says, well, you haven't used it for a bit and I'm a bit short of space and memory, so bang, off it goes. You think, no, we don't want to do any of that. So you have to find the setting in your Android phone that says basically for this app, do not manage it automatically. I will tell you what to do, and basically what you're telling it is you can start it from, it can be started from other applications, it can be running in the background with no interference, and anything else it wants to do. Right now, each phone is different, obviously. You know, Samsung's different to a Huawei phone, but the Android system allows you to do that, whichever phone you got. So that's the app, and I'm not going to go in how the app was actually coded. I'll show you a quick screen thing on how it looks in the development environment for that, and it really is simple. Obviously it's not simple anymore because I've built on, you know, my proof of concept, and it's got more complex as time goes by. But the very simple way of building this thing, it's easy. And as I say, look at videos 36, especially 37, that shows you how to use it in the MIT App Inventor. Same principle, no different. I think the developer or development team moved companies or something like that. I can't, allegedly. Well, I don't know the actual ins and outs, but that's what it sounds like. So, thinking about the Arduino then. The Arduino, obviously I won't be using a full-blown Arduino in the final project. I'll probably use a Nano or something. I will be using this though. This is an HC06, not an HC05. The difference basically is that an HC05 could say to my phone, "Oi, I want to pair with you or connect to you." You have to do the pairing bit manually, of course, but I want to connect to you, and the phone will go, "Oh, okay, yeah, I see you're there. Great, I'll connect." An HC06 cannot initiate a connection. It just sits there waiting for something to happen, which I think is the right way to do it for this. We want the phone to say, "I'm trying to connect to a device," and eventually it might find it as you get to within range, and it goes, bang, I'm connected. And that little funny MAC address down the bottom, not the name RSB, which I've given that the name RSB, just my initials for now. That MAC address is the unique address of that device, so that's how it does it. In fact, if, as you can see at the moment, the red light is steady, which means we're connected. If I press this select BT device, the first thing it does is disconnect. So now you can see it's flashing, and it goes, well, which one of these things do you want to connect to? And the answer is, of course, the RSB one. So we press that, and it's connected and said, yeah, that's it, I've done it all. And then every 10 seconds, it checks the battery. Now, I don't know if you heard that vibrate, but I've set it to vibrate when the battery level changes, purely for debugging purposes. I knew what was going on. Unfortunately, this phone, this is a Hawaii Peace smartphone, has got the weediest vibration I've ever known in any phone. In films on TV, you see phones like this sort of vibrating themselves off a table or something. This couldn't vibrate the skin off a rice pudding, I tell you, it's so weedy. So what I've also done is put this little send me a sound, and the sound I just uploaded from my Windows thing. It's some kind of alert thing I found in the Windows media file. So if I press the manual one, did you hear that? Do it again. That dunk just means, oi, something's changed. Well, I'm forcing it to do it by pressing that button. Purely for debugging, that'll probably disappear, because all this now is done automatically. Right, let's have a look at the very simple Arduino Sketch, which basically is based on that one from video 37. You basically wait for a connection and then you just receive stuff. You go, is there anything for me to receive off that Bluetooth device? Oh, okay, I'll take it. Now, because the value of the battery is between 0 and 100, we can just send a 1 integer value, a short integer, so a uint 8_t, or a short int, not a double, not a standard integer, because that'd be 2 bytes. So let's have a look at the code first, and you'll see how easy the Arduino side of things is, at least. So this is the very simple code. There's a lot of blurb at the front because we do have to change the level of the voltage from the Arduino from 5 volts to 3.3 volts for one of the pins, the TX pin on that Bluetooth module. Big warnings on that. In fact, if you watch video 37, it will tell you a lot more about that. So there's just a little bit here about how to do that with 2 resistors, which is exactly, if I go back to the workbench, the 2 resistors you see on there. That's all that's doing is changing the voltage from 5 volts from here down to 3.3 for that one, and that's all that is doing. Okay, very, very simple. Right, back to the code. So basically, we're just setting up the Bluetooth device here. We do set it. Oh, I've got software serial, because we don't want to use the TX and RX pins. We're using that for uploading code. So we're using software serial. I'm using pins 4 and 6. 4 is the out and 6 is the in. So yeah, that's all we're doing here. And we're saying 9600 baud. It's nice and slow and nice and steady. And believe me, the range of that Bluetooth module I've got, I can leave my workshop, go all the way to the other side of the house, and it's still connected. Absolutely amazing. Right, so all we're doing in this loop here, we're saying, well, while there's stuff to receive, go and receive it and print it out. Now I've got a while, because I'm expecting, as things go on, to receive many more bytes, because it's not just the battery level I need, it's the level at which we need to start charging, the level we need to stop charging, the battery level itself, that's 3 items, and well, that's probably about it actually. I don't think there's anything else we need to transmit to the Arduino. So the Arduino does all the logic. The phone just goes, you're either charging me or you're not, I don't know, I'm just giving you information and you switch on the charger or not. So how's the Arduino going to turn the power on and off? Well, it's very, very simple. We're going to use a MOSFET, probably an SI4599, so that's a dual MOSFET. The Arduino switches the N-channel MOSFET on. We've covered all this in previous videos. The Arduino switches the N-channel MOSFET on, which then in turn switches on the P-channel MOSFET, which allows power to pass into this desktop charger that I was talking about. Of course, it doesn't have to be a desktop charger. It could be anything. It could just be a cable. This is going to plug into the Arduino controlled module, and a cable will come from here into the phone or this charger. Okay, so that's how I see the thing working, and it is the Arduino side is so simple. It's embarrassing, quite frankly. It's just a very simple, I'm receiving 3 values, a little bit of logic, should I switch on the charger or not, the end. And now, of course, you could make it a lot more complex than that. You can have LEDs on the Arduino side of things, which I probably will, like if there's not a connection on here, but this thinks it is connected, then I might have an LED to say, oi, something's going on. Or I might have an LED on there to say, I'm charging at the moment, or no, I'm not. In fact, a bi-colour one would be good for that, wouldn't it? Red, I'm charging, green, everything's fine. You know, you can make it as complex as you want, really. You can have an LCD display if you really wanted to. I'll probably keep it fairly simple, couple of LEDs, and that'll be enough. Now, okay, let's think about writing code for an Arduino phone. Now, if like me, you're thinking, I haven't got the faintest idea how to do that. Well, 4 years ago, that was exactly the case, but a bit of Googling makes it like, really? Is it really that simple? My goodness me. The small caveat is that when you create your own applications and you don't put them into the Arduino Play Store, after all, why would you? They're yours. When you download that file from the integrated development environment for the Android, it will say, okay, you've downloaded this. Oh, hang on a minute, you can't install this because you've not told me you're allowing installation of programs from anywhere but the Play Store. But there's a setting once again on Android to say, yes, I can install stuff from elsewhere, and it will say the universe will implode if you do that, and you will probably catch some awful disease. But you say, look, it's okay, it's my code. So you go, yes, I'm allowing it, and it just installs it. Now, of course, you can just do that for your code a few times, then set it back so you don't accidentally install something else from some malicious email or whatever. It's basically what I do, and everything's fine. If I can actually get this code on this phone up into the Play Store for you guys to just download and use without having to create it, I will. I'll give you a freestanding version of this code when it's complete. Obviously, you won't be able to change the colors on it. It'll be just an app. But to be quite honest, this app is going to run in the background. Although I've got the foreground here, this is almost like a settings screen, isn't it, with all the things you want to do. And after that, you just hit the go back into the background, if I can do it. I think my eyes are definitely, there are. Go back into the background, and that's it. You never hear from it again. Unless, of course, you've got the noise or the vibration set on. And every time the battery changes, then you might feel or hear something. But basically, that's all it's doing. So yeah, it's pretty simple stuff. Right, okay, enough talk. Let's have a look at the integrated development environment for the Android Now there's quite a few out there, but as I say, I went from MIT Inventor 2 to Appy Builder, which no longer works. They've moved to Codular. Let's have a look at that. Right, so this is the Codular development environment. What you're seeing there is a picture pretty much of what you saw on my phone. It's not 100% because, as you can see, the emulation here is for a Samsung Galaxy Note 5, which I haven't got, but it's close enough. There's various others you can pick from there, as you can see, but that's close enough. Now, the thing about this development environment is that there's a companion app, which I mentioned. You download that onto your phone from the Play Store, and it somehow magically links your phone via the wireless network to this development environment. So as you make changes on the development environment here, it changes it on your phone as well. It's sort of a two-way thing there. And it works quite well until the link gets broken. And then you have to kill that thing because I can't exit anymore. Let me give you a quick example of what happens. So we're running here on the development environment, and this is linked now to the screen. But if I try and exit, obviously I'll put something in there to say you shouldn't really be exiting because it won't work anymore. Okay, so I say, yes, I do want to exit, but then it says down there, oh, you can't because you're in development environment. So now I'm a bit stuck. So you have to actually kill the app and start again. And the way you start again, you point your phone at the screen, and you get a barcode come up and it just links in quite magically. Basically, have a go. You'll see exactly what I mean. So this is what it looks like, and the elements that you put down here are all listed down here. And of course, initially it's all a bit overwhelming. You go, I don't know what a layout is. I don't know what this is. But literally, this has taken me so far 2 days to do. Well, 1.5 actually. 1.5 days to do. I've been learning along the way. Obviously, I understood the principles from that previous video, but that was a long time ago. And yes, I did have to watch my own video to understand how to do all this. I thought, I can't remember. That's 4 years ago. So I had to watch my own video and go, ah, yes, I sort of remember now. So I understood the basics, but of course the individual elements and stuff you can put on this screen, I had to work out, little bit by little bit. And Google is definitely your best friend when it comes to that. The Codular documentation is very good, and it does pretty much cover everything. There's not many examples though. It gives you the parameters you can put on, but it does actually show you the built product and go, this is what it looks like when you've done it. So that's the only caveat I will give to that. So this is the GUI then, the front end that you're looking at on this screen. But over here, if we click over here, say, there we are. Now all this, and it's all a bit overwhelming at the moment because there's a lot here. These coloured blocks are the code. So for example, if you want a control piece of code, basically an if then else or something, you click this thing here, and then you can choose from all this, if then whatever, blah 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 blah, and you just drag them, click them, and you drag them over here, and that's what the orange blocks are. Now having got an if or a when or whatever, when is global sort of, continually looking. If you've got an if, you then have to plug in conditions to that, and that's when you think, well, okay, what's the condition on? Is it on one of my variables? Is it on one of the elements on the screen? And let's just I'm finding it hard to see the screen, but let's just say on this label max charge. Okay, that's a thing on my screen to show you what you've chosen. You click on that and it shows you all the possible things that you can add on. The green things are properties, and the purple are procedures that you can call, and these are sort of global events up here. When this happens, do something. So it's pretty simple. I wouldn't dive into trying to do this without having watched video 3637. It is, once you've done that, you'll have the background enough to do this. But as I say, what I intend to do is actually create this and put it up on my GitHub so you can just download it, or if possible put it onto the Play Store just for free for people to download. Of course, it won't mean much to 99% of the population because you do need an Arduino to make best use of it. And I have no idea how to get stuff into the Play Store. If there's any cost involved, I'm not going to do it because I'm not going to charge for this. So this is more than a proof of concept now. I think this is sort of almost good enough as a sort of a beta product. I've still got a few items to put into the database that I store. database. It's a lovely word, isn't it? The tiny little file that it uses to store some of these values. And then I think I'm just going to get an SI4599 dual MOSFET chip, which I've got here in one of my drawers. I don't know if I'll be able to actually see enough to solder those on yet, though. So that might have to wait until I get my eye done. Oh, eye update. I've got an appointment on the 21st of March 2020 to have the pre-op assessment, which is when they measure the eye, discuss the strength of the lens and all that kind of stuff, and then they determine how urgent is this. Yeah, can we leave it for a month? Do you have to be done within the next 2 weeks? So I'm praying that they're going to do it within like the next 2 hours after they see me, because I can see nothing out this eye, and this one's getting worse and worse. So we'll just see what happens on that score. Okay, so after sometime March, April time, with any luck, this patch will disappear, and I can't wait, can't come soon enough. Great, okay. Now, I can't really show you any more about this really. I mean, obviously I can play about with this and show you what it does, but the principle of transmitting values from the phone to the Arduino via that. Oh look, we've lost connection. Wonder why. It says not connected. We must have done something. I say we, the royal we, obviously. Yeah, well, let's connect again, shall we? Stop it going mad. RSB, that one. Is it going to connect? Yes, there we are. I have found, incidentally, if this is just sort of left next to this device, so in my phone charger, for example, so if that's plugged in there, and this is, you know, within 2 or 3 meters, it's absolutely rock solid. It doesn't just disconnect like we just shown there. Maybe it's because I'm in the development environment. It's just rock solid, as you'd expect from Bluetooth. I mean, you don't get your Bluetooth speakers suddenly disconnecting. What you do, oh, sorry about that, but normally they stay connected once they're connected. So yeah, I've no qualms about that. And in fact, the code, going back to the code again quickly, most of this code, or a huge amount of it, is what to do when things go wrong. So, you know, what happens when you can't connect? What happens if you can't transmit? Or what happens if this module here is no longer receiving commands and things like that? Now, the only time it knows there's a problem is when this tries to transmit a value. Now, at the moment, I've got this down to every 10 seconds, which sounds a bit extreme, doesn't it? But for development purposes, it's fine. But in real life, I might do it every minute. But that means a whole minute could go by without you knowing something's wrong. So what I might do is have the Arduino talk to the phone, going, hello? And the phone goes, yep. And that's it. Okay, like a heartbeat, really. You there? Yep. You there? Yep. And then suddenly this goes, oi, I've got some data for you. Here's the battery level, the new battery level that's changed, plus the min and max charge levels. Do what you have to do. Simple in concept, but there's an awful lot of error handling. What if this goes wrong? What if that goes wrong? As in most code, it's the error handling that takes the time, doesn't it, in all the particular scenarios. Right, I'm going to stop now because I feel like I've waffled on long enough. I can't do any of the intricate soldering type projects at the moment, but as I say, fingers crossed, you know, things are moving on apace. If you got any, oh, by the way, if any of you know of an app that already does this, you know, talking to some microcontroller to say stop charging, please do not tell me. I don't want to know. This is a project that's been on my list literally for years. I've always wanted to do it. I've never really looked to see if there was something that does it already. So I don't want to know if there's something out there, right? This is going to be a unique Ralph Bacon production of the phone talking to an Arduino or a Nano, probably via Bluetooth. So keep that information to yourself. I said no, I said keep it to yourself. Stop telling me. All right. I think it's going to be pretty good for me, because that means I can charge my phone up to 80% while it's sitting in my workbench. And when it drops down to 70, it will start charging it up again. Now, of course, there are times when you do want it to go to 100, like you think, oh, I'm going out tonight, and I definitely want it stuffed to the gills with power, at which point you just switch the thing off. So it doesn't run anymore. Perhaps I'll have a little switch on the Arduino side to say, I'm ignoring everything you tell me, and I'm just going to charge you to max. Something like that. It'll all come clear in due course, whenever that is. But as I say, I'm very hopeful that this is now going to become a proper project, because it's something I've wanted to do for ages. Right, that is it. If you've got any comments about this, apart from there are already 13,000 apps that do this. I don't want to know. I'd love to hear from you. By the way, thank you very much for all your comments on my last video about me being unwell, which I'm not 100% yet. I'll probably sound okay now, but I'm definitely weak. I didn't take the dog out today. I've took the dog out twice by myself for 2 days running, but today not so good day, so I'm staying indoors. But I am definitely getting stronger, so things are looking up. Your comments, I've read all of them. A couple of them I just clicked a heart on them because they were particularly good, but I mean they're all very, very good, and I thank you dearly for those comments wishing me well, and I'm sure I will get well. And of course a lot of you mentioned my eye as well, so that's looking as though it's moving apace as well. Great. Okay, I'm going to leave it there. I'll have to cut down this video by about 60% to fit it into a short video, but in the meantime I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.